friends, welcome to Magic Mustache Math. I am Miss Cosmos and this is topic 10 review, pages 484 through 486 in your math textbook. So the first page is going to look like this, and remember we are not doing this side, but I do need you to rip this out and flip it over because we will be doing the vocabulary. So number 1. For these, we're going to write T for true and F for false. So, the fraction 3/4 is a multiple of 1/4. That is true because we could take our unit fraction 1/4, 1/4, 1/4. We add these all together and we get 3/4. Equivalent fractions are fractions where the numerator and the denominator have the same value. That is false. Number 3, the denominator of a fraction tells the number of equal parts in the whole. So if we had the fraction 2/3, our denominator is the number on the bottom. So yes, that tells the number of equal parts that we have in our whole. So that is true. Number 4, a fraction names part of a whole, part of a set, or a location on a number line. This is absolutely true. Number 5, the numerator is the number below the fraction bar in a fraction. So if we have our fraction 2/3, it's saying that the numerator is our 3. That is false. The numerator is the number on the top. Now, for these, numbers 6 through 8, we are going to write always, sometimes, or never. So let's read this through and see if we can make sense of it. A unit fraction blank has a numerator of 1. Well, the numerator is the number on the top, and I know that my unit fractions all have 1 at the top. So I'm going to say always. Number 7, a numerator is blank greater than its denominator. Well, most of the time, I think we would like the number on the top, to be smaller than the number on the bottom, but they are sometimes larger, so I think I'm going to have to go with sometimes. And number 8, a mixed number blank has just a fraction part. Just a fraction part would be like my 1/4. But if it's a mixed number, that means it also has a whole with it. So we're going to have to go with never. All right, my friends, go to page 485. And we are going to work on number 1. This is set A. So remember, you can find the product of a whole number and a fraction by using repeated addition or properties of multiplication. So for number 1, we have 6 times 3/5. Now, if we're using repeated addition, we are going to have 3/5 5 times. So 1, 2, 3, 4, 5. And these are all added together. This is our repeated addition method. So if you are adding and subtracting fractions and they are all the same number on the bottom, your denominator stays the same. We don't do anything with it. And then we just add across the top. So 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15. So my answer is 15/5. And if you want to turn this into a mixed number, you don't want to leave that number larger on the top than it is on the bottom, all you have to do is, especially if you see this right here, 5 and 15 go really nicely together. I can read this 15 divided by 5 equals 3. So I have 3 holes in 15 over 5. Number 2, 5 times 5 eighths. For this one, we're going to go ahead and try our properties of multiplication, our associative property method. So what they want you to do here, they want you to know that if you take this fraction right here, all this fraction right here means is it is 5 times the unit fraction of 1/8. So if you take 1/8 times 5, you'll get 5/8. And so we have this in parentheses and we're timesing it by 5. Okay, so now we have our new equation down here. We've broken this down into this. Now, our associative property of multiplication tells us that we can multiply in any order and our product or our answer will be the same. So now we're going to put the parentheses around our 2 holes and have 5 times 5 times 1/8. So 5 times 5 is 25 times 1/8. So we've just made this a little bit simpler. And now that we have 25 times 1/8, what we would do is if you're doing repeated addition, you know that you've got 25 1/8. You know that that's going to end up being 25 over 8. If you don't feel comfortable with that, doing it in your head, there is our super secret method of just putting a 1 under our 25 and multiplying across. 25 times 1 equals 25, and then 1 times 8 is 8. So now we have our improper fraction, our fraction that has a larger number on the top than the bottom, and we're going to pull out our holes. Now, I know that 3 times 8 is 24, and that's about as close as I can get to 25. So 24 over 8 is 3 holes, and then I'm going to subtract. 25 minus 24 is 1. My denominator stays the same, so I end up with 3 1/8. Number 3. 4 times 12/16. Now, I'm going to go ahead and use our picture method here because 16 and 4 go really nicely together. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, I did that wrong. I did that totally wrong. We don't have 16. We have 4 holes. So 1, 2, 3, 4. Now what I can do is I can cut them into 4 parts in order to make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 equal groups. So see how I've cut them into fourths? This is just like when we take our 8 and we cut it in half to make the number of parts that we needed. Now I'm going to color in 12 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that gives me 1, 2, 3 holes. So my answer is 3. Set B. Use a model to help find a product. So for number 1 in set B, I have 3/4 times 8. Okay, so with my model, I'm going to have 8 holes. 1, 2, 3, 4, 5, 6, 7, 8. And we are going to break them up into 4 equal groups. Now, I know that 8 divided by 4 is 2, so I'm betting I'm going to have 2 in each group. 1, 2, 3, 4 equal groups. Perfect. And 3 of those groups are going to be colored in. Remember, when you are coloring in the groups, not the individual holes. But now when we go back, we're going to count the number of holes in our groups. 1, 2, 3, 4, 5, 6. So the answer to number 1 is 6. Number 2. I have 7/10 times 50. Now, I am not going to draw 50 little circles. So I'm going to use our super secret method of putting this 50 over a 1 and then multiplying straight across. 7 times 50. Again, that is a very large number. I'm going to work out the math using my standard algorithm for multiplication. 50 times 7. So we do 7 times 0 is 0. 7 times 5 is 35. So my answer is 350. So 7 times 50 is 350. And then we do 10 times 1 is 10. Now, one of my little tricks, if you have zeros on the top and the bottom, you can just cross those out. And now what you're left with is 35 over 1. And any number over 1 is just that many holes. So my answer is 35. Okay, number 3. Why don't you guys go ahead and pause the video and try to do this one on your own. Go ahead and try it on your own and unpause the video when you're ready, and we'll work it out together. All right, so number 3, we have 2/6 times 3. Now, I can do my picture method. I can have 3 holes. 1, 2, 3. Now, I need to make those 3 holes into 6 equal parts. I can do that by cutting them in half because I know that 3 times 2 is 6. So if I make each of these into 2 parts, I'll have my 6. 1, 2, 3, 4, 5, 6. Now my number on the top tells me how many need to be colored in. 1, 2. So my answer is 1. If you used the super secret method, you would have put your 3 over 1 and multiplied across. So 2 times 3 is 6. And 6 times 1 is 6, and we know that any number over itself is 1 whole. Same answer. All right, my friends, I am going to go ahead and stop the video here, and we are going to do a part 2 to continue on with set C. So I will see you in part 2.